Yeah, hello friends. Good afternoon. Am I audible? Can you hear me?
Yes, sir.
Yeah. Well, friends, so let's continue with the session. So in the session today, let's say already we started off with Kubernetes. So today, let's understand some more aspects in Kubernetes, like what is a deployment and what is a daemon set. By the way, did we cover a daemon set concept the other day? Yes, no, maybe. Daemon set cover చేసామండి. Anyone?
No.
No? Okay. Well, friends, so let's today then unfold the concept of daemon set. So what is a daemon set and what it actually does, the functionality, everything, in detail, let's try to explore. So without any further delay, let's get started. So a daemon set, the explanation for daemon set, it goes this way. So friends, you tell me, we are connected to this meeting, a Zoom meeting hosted by Career Bridge. All of us, we are connected to this Zoom meeting. So all of us connected through various devices online today, right? Ravali, Venkat, Balraju, Sarika. Yeah, we got a couple of participants today. Mallikarjun, Prasad, Varaprasad, and so on. So all of us got connected to this meeting. And what is common in all our machines or in all our devices? Yeah, friends, what is common?
Zoom.
How are we connected? Perfect. Perfect. So Zoom, an application called Zoom is common in all our devices. And through this application, we are connected and we are, having this conversation taken forward. Meaning, how many Zoom applications did you install? Multiple or just one application of Zoom installed on your machine, sir?
One.
Only one occurrence of Zoom is sufficient for us to get started off with this meeting. And of course, even you try to install multiple Zoom, you run Zoom multiple times, you get only one occurrence of Zoom installed on your machines, right? And this is what the concept is pretty much, pretty much closer to a concept called daemon set. Everyone here, who is in the meeting, they should qualify something which is nothing, something that is a Zoom application on their devices. If Zoom application is available, then they are good to connect to this meeting. Right? They're able to get to this broadcast meeting and get my voice and get this visualization displayed. So one occurrence of Zoom, nothing more, nothing less, just one occurrence of Zoom on your machines is absolutely fine to get going with this discussion. Now, coming to the part, meaning the daemon set concept. Even in daemon set concept, the discussion is the same. Now, say friends, in Prometheus we discussed it. Let's say this is my Kubernetes master where I installed Prometheus 2, and I want to I want to monitor the health status of my servers, my worker nodes. So what component should my worker nodes have? What component should my worker nodes have here, friends? How Prometheus collects the data from different, from different platforms? How Prometheus is collecting the data? There's something called a exporter node, right? There's something called an exporter that acts as an agent program, and that lets the users, or sorry, that lets to collect all the data of the server and write that data into Prometheus TSDB, time series database, right? So one occurrence of exporter only required to make sure that the metrics of the servers of all these worker nodes are collected and added to Prometheus into a data store called TSDB, time series database, TSDB, right? So now, friends, now with this understanding, just try to get the idea. This is my Kubernetes master. This is my Kubernetes master. And to collect all the metrics of the servers, the worker nodes, all I got to do is get the get the metrics of these exporter nodes added to my Prometheus master. But later I'll visualize that and get to know what's happening with my worker nodes here, the status of my worker nodes, etc. But friends, the idea here is at least one exporter node is required to get the metrics of the slaves onto Prometheus master, so that we collect all the metrics and get the information about them, what activities to take, or should we scale up the server, scale down the server, perform some activities. Everything will try to get an overview of. Now, say one of the servers got failed, or one of the server is detached. Now, we don't want that server's metrics anymore, meaning that exporter, I don't want it anymore. I want to monitor only this 4-node cluster. If at all tomorrow I add, let's say, some 2 more nodes. Now, what should happen? I should get the metrics of these 2 nodes, meaning an exporter node should be present on this node, right? An exporter node should be present here. Oh boy. Exporter should be present here, likewise an exporter over here. Why is that? Why is that? Because exporter is the only node that collects the metrics of your servers and add them to TSDB of Kubernetes master. Again, the day after tomorrow, I'm adding some more servers. Now, what should happen? The more servers you add, you should collect the metrics of all those servers. Meaning this exporter node should scale up and get added in all these available or newly added nodes. Exporter should be created automatically in these nodes, so that what happens, we get all the metrics of these servers. So I want such arrangement. That some pod should always be present in all the nodes, and the number of occurrences, again saying I want only one occurrence of a pod in the Kubernetes cluster in all the workers. So friends, the concept here is very simple. My requirement is that one object of Kubernetes to be present in all the worker nodes. Only one occurrence of the object, not multiple, not replicas, just one object to be present. If there are 10 servers in all the 10 worker nodes, there should be one object present in all those 10 servers. If there are only five occurrences of that object should be present in every node, one object per node. That is my requirement. Not more than one, nothing as such. So daemon set is a concept that allows you to make sure that based on your cluster size, a daemon set gets or increases its desired state. Now say friends, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, total 12 node, 12 worker nodes here. In this cluster, there are 12 worker nodes. But let's say if I delete these 3 servers, now my cluster size is only 9, right? So the daemon set's desired state should be now only 9, because there are only 9 nodes, and daemon set should get updated accordingly and should hold only 9 nodes. Again, what if I delete all these nodes, and now Kubernetes cluster is with only 3 workers. Prometheus cluster is only with 3 workers. Then what should be the daemon set's what's the ideal state? The ideal state of a daemon set should be only 3 worker nodes, 1 master and 3 worker nodes, and a daemon set should hold only 3 pods in each, and or only 1 single pod in all these 3 worker nodes. Yeah, friends. So based on the way how you scale up your cluster or scale down your cluster, your daemon set should fluctuate. And the overall idea here is not a replica set or a replication controller. It's a daemon set. It ensures that only 1 pod is created per per server or per worker node when it is defined as a daemon set. So why not replica set, friends? Why not replication controller or replica set? Let's say this is my Kubernetes master, and I got a worker 1, worker 2, and a worker 3. I got worker 1, worker 2, and worker 3. Now, excuse me. If I create some pod and define that pod in a replica set, right? Replica set, and if I say replicas are 3, meaning the number of replicas are 3, what happens, friends, if I say replicas are 3? Now, let's say one replica here, one replica here, and one replica here. The definition of daemon set is satisfied here, right? In this content, in this context. The definition of daemon set is satisfied, but we are doing things with a replica set. Then what is the problem here? What's the problem here? Replica set. Say, friends, tomorrow you're adding few more servers, 1 server, 2 server, and 3 more servers. Now, a replica set cannot guarantee of making that a pod available in all these servers, one replica of the pod available in all these servers, because the replica set's desired state we gave is 3, and 3 are already fulfilled. Now, if you add 3 more new servers, you don't get your cluster up and in a desired state. Again, you have to go to replicas and increase the count to 6. But if we increase the count to 6, can we guarantee that the replicas are maintained this way only? Yeah, friends, can we guarantee that the replicas are maintained in the same way, like 1 pod per server? Not really. Maybe your replicas might get created this way, like let's say 2 replicas here, 2 replicas here, and 1 replica on a new server. Meaning our required status is not getting satisfied. Yeah. What is our requirement? What we are anticipating that is not getting fulfilled. So that is where we completely rely on a new object type called daemon set, which a daemon set, you don't need to, when you add more slave nodes, you don't need to define again, jumping back to your daemon set that now the servers are 6. So the number of pods maintained in every server should be one identical thing, and that should be total 6. No, you don't need to define anything at all. Based on your server size, based on your cluster size, a daemon set does its activity of auto incrementing and making sure your pod, which is defined in a daemon set, is available at every server level. Yeah, friends, are we following? Yes, no, maybe. If yes, let's go do a quick, quick example. Let's jump to console. Let's jump to this site called Play with Kubernetes. I'll show you some example on Play with Kubernetes, as well as I'll show an example on my Google Chrome. Google Cloud Server 2, console.cloud.google.com. In both these areas, let's give a try. So I'll create a cluster here. Wow. Is there a cluster already created? No. Very good. So yeah, friends, now let's create a cluster real quick. So jump here and yeah, friends, any questions? Create.
స్క్రీన్ కనిపించట్లేదు సార్.
ఎప్పటి నుంచి అండి?
జస్ట్ ఇప్పుడే సార్ మీరు.
అవునా? ఓకే, స్క్రీన్ స్విచ్. యా, ఓకే ఓకే అండి.
ఓకే సార్.
యా. Okay, friends, let's go create a cluster. Likewise, let's do an example over here to Play with Kubernetes. Play with KTS.com. So at times in the industry, you might hear, are you running Kate server? So when they say Kate server, make sure that it's all about what's it, Kubernetes. People call Kubernetes as K8s or Kates. Okay, both of them, are meaning Kate server, meaning they're referring to Kubernetes only. Yeah, they're referring to Kubernetes. So let's wait, friends. Let's jump to this site. Login and Docker. Start. Yes, just give me a minute. Am I audible now? Can you hear me? Friends, am I audible?
Hi, sir.
Friends, am I audible now?
Yes, sir.
Yeah, okay, friends, just a second. Reload. Your connection was interrupted, okay? Okay, friends, fine. So how to start a cluster, we already know. What we do here, we got to copy this very first command, right? Control F and insert, Shift F and insert, enter, and Kubernetes node is about to begin. And followed by that, on node 2, you make it as a worker and add new node. Node 3, we turn it as a slave. Okay, so let's do it, friends. Second command I have to copy. Run this command in node 1. So node 1 still process happening. Let's wait for some time. Yeah, okay, friends. Shift F and insert. I got to copy this command, Control F and insert, and place it in. On this token, I got to copy and paste it in, what's say, my worker nodes. Control F and insert to copy. And over here, let's see, it's on this token, and in node 3 as well. We got to run this token. Now, friends, I'll take the copy of this elsewhere for our reference a bit later. Okay, and node 1 happening. Let's wait for some time. Node 3 is also over. Now on node 1, I have to enable this network thing, and then we are good. Taking some time. Okay. Yeah, friends, done. So now let's run the command kubectl get nodes. KUB get nodes. Let's have a look. Well, the nodes are not yet ready. Let's wait for some time and make sure that all the nodes are ready. So node 3 is ready. Node 2 not ready. Node 1 not ready. Let's wait for some more time to get, yeah, all the nodes are ready. Node 1 is ready. Node 2 is ready. And node 3 ready. Now, friends, I'll write a manifest and you should understand what is this manifest and what it does. Okay. So vim manifest1.yaml. VI of vims. Let's go with the VI manifest1.yaml. Manifest 1.yaml. .yaml, enter. And now see, I'm going to write a manifest. It goes this way: API version, very slow. API version, let's say v1, kind, let's say, sorry, API version is for a daemon set apps/v1. Apps/v1. Kind is equal to DAEMON SCT, D in caps, S in caps. API version kind, metadata, give a name to your daemon set, let's say name, or let's go with the name, my DS, and then spec section. And within spec section, what you do, here you got to define what's a few things. Daemon set, for a daemon set, what you add a selector and you got to match the labels of your pod. So over here, I go with selector and let's say match labels. Match labels and match the labels, let's say pod and my pod. And after that, we got to add a template and add our pod details here. Metadata, and we got to add the pod metadata here for labels, let's say metadata, and here labels. And here we go with the pod, my pod, my pod, and then spec section. Under spec section, what we do, we add things like the container details. So over here under spec containers, containers, CONT. Containers, and here, friends, what I do is that I'll add container details like -name, container name C1. Next, let's say image, nginx. Next, let's go with ports, RTS, ports, and let's say here container port and some host port.
Nginx spelling mistake on sound, sir.
Yeah. I understood that. Yeah. Container port. Yeah. నేను టైప్ చేసిన గంట రావట్లేదండి ఇది. Container port. Let's say 80. Spelling wrong, right? So let's go correct it. Nginx. Let's save the document. Escape :WQ. Enter. So now, friends, now what I do is I'll create, I'll run this manifest. What do you think? What are the objects going to get created? For now, kubectl get all. Again, kubectl kubectl get all. Hellboy. AUBECTL space get space all. kubectl get all. Let's hit enter. And see, friends, we got only one service present in the default namespace. Now I'm going to create what say run this manifest. kubectl apply minus f manifest one. Dot YAML. Now, what's going to happen, friends, when I run this manifest? Let's find it. Label spelling data. Okay. Labels LABELS, not LABLES. Let's find the mapping values are not allowed in this context. Okay, line number 12 again, there's an error. Under template metadata, yeah, labels, here we go to add, what's say, colon, escape, colon, WQ, save and quit. And now let's again run the manifest. And have a look, friends. What happened at daemons? And you tell me if you understood the definition or if you understood what say the explanation what we had so far. Just have a look at this cluster and tell me how many pods are created. Yeah, for this daemon set, how many pods are created? Yeah, friends, what's your answer? How many pods? 1, 2, 3. Friends, are we connected? Am I audible?
One pod is created.
Sorry?
One.
One pod? On every worker node, there should be, what say, one pod created. So there are how many workers here?
2.
2 worker nodes. So on every worker node, there should be one running pod available. So what is that mean? How many pods?
2 pods.
2 pods. So let's confirm. kubectl get all and have a look, friends. At daemon set identified that the desired count of the number of worker nodes are 2. I did not mention anywhere in my manifest that the number of pods to be created are 2. No. Nowhere I did that. A daemon set's functionality is defined as such, and we're finding 2 pods. What if we add a new instance? Have a look, friends. I'm adding a new instance, node 4. And in that node 4, let me run this command okay, to add it as a worker. So jumping to node 4, and over here, let's run a command. Just a second, please. Yes, tomorrow onwards I'll be coming online, sorry, offline. Okay, just for today. It didn't happen, and here there are some drilling works happening, and yeah, a lot of noise. Node 3 is okay. Why not node 4? Node 4, okay. Well, friends, I thought of running node 4 and just have a look at let's say how things node 3, and then have a look at our daemon set, how things are going to happen. I deleted node 3, and now let's jump to node 2, and kubectl get all. Still, daemon set says the desired count is let's say 2, but let's wait. We got only a one node cluster now. Sorry, yeah, of course, 2 node cluster where one is the manager and second one is the worker. So now we should find a daemon set, scaling it down, scaling the service. Scaling down a daemon set to only 1. Let's understand that. Just in some time, you find what say the number of reduced to only 1 because we got only now have a look. We got only one worker node and one master. And a daemon set ensures that one working copy of a pod is always available on a worker node. That is what's happening with this example. Yeah, are we clear, friends? Yes, no. Question? Yeah, Sarika, go ahead. Questions?
It's clear, Prashant.
Yeah, well, friends. Well, so let's continue. Let's see one more example.
సార్ మీ వాయిస్ వినిపించట్లేదు సార్.